My name is Hui Wen, and I'll be presenting on behalf of Mossy Creek Team A, Creek Bed and Bank Rehabilitation. My team members are Marcos, Devin, and Jack, and the advisor for Team A is Dr. Strebig, and the advisor for the other two teams are Dr. Castaneda and Dr. Pinpole. And our main client is Mr. Brian Cho of Mossy Creek Fly Fishing. Now, before I go into the next slides, I want to give a brief overview of how the capstone is set up for those who aren't familiar. The overall capstone is called Bridges Over Mossy Creek and is divided up into three sub-teams. Team A, Creek Bed and Bank Rehabilitation. Team B, the abutments, foundations, and roller supports. And Team C, bridge deck and superstructure. And each team has a role to play in designing a bridge over Mossy Creek. Now, Team A is concerned with the environmental aspects of the project, specifically the stream conditions. It would be improper to conclude that only the stream will be affected by this project, as a change to a small creek can ripple across an entire watershed. As you can see in the image provided, Mossy Creek is located near Harrisonburg, connected to the North Fork of the Shenandoah River, which belongs to the Chesapeake Bay watershed. And on this slide, you can see the specific reach or segment of Mossy Creek that we are interested in. We chose this site mainly due to the discretion of Mr. Cho, since it is located within his property. It can be difficult to imagine how making a change to this reach can impact the greater watershed, but changing just one of 8 major variables, either the channel width, depth, velocity, discharge, slope, the channel material roughness, sediment load, or sediment size, would result in a change to the stream pattern, disturbing the delicate equilibrium of a complex natural ecosystem, and potentially causing a domino effect for the rest of the watershed. The National Rivers and Streams Assessments assesses these water bodies across the entire country every 10 years. And they found that in the Southern Appalachians region, where Mossy Creek is located, they found that approximately 50% of the streams and rivers are of poor biological condition. And so in order to improve the regional stream health, we have to act locally and start with the smaller streams that constitute these geographic regions. So why choose Mossy Creek in particular? Well, for starters, in August of 2018, there was a 100 years flood event, or in other words, a flood that has a 1% chance of occurring in a particular year. This flood washed away some bridges that our client and the local community had built along the creek within their properties. An example of one of these bridges is pictured on the left, composing of telephone poles with wooden planks attached. The reason why these bridges were needed in the first place is because the Virginia Department of Game and Inland Fisheries prohibits recreational wading or entering in the stream, as it leaves the possibility of introducing contaminants and foreign species into the ecosystem. Mossy Creek is one of the regional destinations for fly fishing, which is why our client's business, Mossy Creek Fly Fishing, Trout Unlimited, and the regional fly fishing community are essential stakeholders for this project. It is important for us and for them that the health of Mossy Creek is maintained. For this project, the goal for Team A is stream restoration design, which is an umbrella term for a large array of different potential projects, depending on the specific project goal. To determine what that goal is, our team has been researching into stream restoration for the past 2 semesters. We've also attended a workshop coordinated by our advisor and a local engineering firm, Bowser and Associates, as you can see from the images on the slide from that workshop on the day. They taught us the fundamentals of topographical surveying, differential leveling using a site level, as you can see in the image on the right, and mapping out cross sections of a stream, which produces valuable information needed to be able to assess the health and the conditions of that stream. We've made design decisions to make our data collection even faster and more accurate by replacing the aforementioned site level with a rotary laser level, which does automatic measurements. Sadly, we won't be able to apply these skills as planned this semester for preliminary data collection until the fall, but it has been exciting to learn and develop professional skills related to stream restoration design. Currently, the team has planned to conduct two types of assessments and use that data to create a model of the channel using a program called River Morph. Two assessments that we're planning on using are the Stream Visual Assessment Protocol version 2, which is a national protocol used for evaluating stream health using qualitative observations of the stream's physical conditions, and levels 1 and 2 of the Rosgen stream classification technique, which determines the stream type. The classification guide for the latter is pictured on this slide. To give a brief breakdown of this guide, this is level 1 of the Rosgen technique, the broadest of the 3 levels. And to be able to classify a stream using this level, the dominant slope range, cross-sectional morphology, and plan view of the stream is needed. And this information can be determined using aerial photographs taken, as well as using the values from the differential level at the site. And the results of this classification is a capital letter, as noted at the bottom of the guide. And this is used in level 2 for a more detailed classification. And so the Rosgen technique is important because it can be used for informing stream restoration measures and goals, both of which are highly relevant to our project, as the results of this classification will inform the team on what measures, if any, must be designed to better the health of the ecosystem. And so moving forward from now to the fall semester, the plan is for the team to continue research into stream restoration design so that when the next semester comes around, we will be adequately prepared to conduct the plan assessments and to collect data that will inform our design, as well as help inform the other 2 teams on the conditions of the stream bed and banks. Thank you for listening. I will now take any questions.